Okay, so today I'm looking at a friend's bench power supply. It's a BK Precision 1735, I believe. And the problem with this is, when you turn it on, only the bottom display lights up. The top one will light up, he said, if you... There you go. So it seems like there's a bad solder joint or a cold solder joint somewhere. He's just now getting into electronics. He wants to play with some Arduino stuff. And so he's just learning, and he said he's just a little intimidated by taking it apart. Something like this is usually an extremely easy fix. You just take it apart, find the bad solder joint, touch it up, and you're back in business. Alright, so let's take this here, shut this off. Now this screw up here, looks like it's going to give us some problems. Oh, there it goes. And when I banged on it, the display didn't just come on, it kind of looked like it had to initialize. So it's not so much the, the display or the LED portion that I think has a bad solder joint, because that would usually just fade in and fade out. It might be the power going to, to the display or to the meter. But we'll find out. Okay, so now we got it open. Get this wire out of here. Let's take a look at the inside. We got two very large capacitors here. So I'm going to discharge those before I go any further. So this is where the problem's going to lie. So let's take the front panel off. Let's see what kind of trouble we can get into. It looks like he or somebody else already had this apart, or took it apart to fix it, or attempted to fix it, because some of these screws are already nicked. Okay, so that's all out. Now, the one that we're worried about is the top one, this the voltage meter. Now usually something like this, when you have an intermittent problem, especially where, if you bang on it it'll work, you want to power it up and start moving wires around. But I get the feeling that because of the design of this, the layout, I have, it's going to be difficult to do that. But I have a feeling that if we take this all apart, be able to actually see the bad joint or joints and touch it up. I like how they put that in. They just held it on with hot glue. I'm wondering if that was like that originally, or if somebody was in here and that's how they put it back on. Alright, so first things first, let's just take a look. And being that each of these have their own controller, this is a self-sustained unit. Okay, so one thing I'm seeing right away, see if I get the camera to focus. This is a 7805. It's a 5-volt regulator. And I don't know if you can see that too well. Let me see if I can zoom in even further. But I don't know if you can see that, but there's like no solder on the pins. It looks like somebody replaced it and forgot to solder it, or it was getting really hot. But from the looks of it, it looks like somebody replaced it and forgot to solder it back in place, which would cause the problem that we're having, because this is the, I'm willing to bet that this, 12 volts probably comes in and that brings it down to 5 or whatever. Don't know off the top of my head, because it's the first one of these I've worked on. So let's first things first, let's just get all the old solder off and resolder it. So since I don't have any flux on hand, I'm just going to add a bunch of solder to it. Way too much. And then I'm going to use desoldering braid. To clean it all off. So now the majority of the solder is there. I wonder if you can see this on camera, but you can actually see the blue mat underneath of it, because the pins are barely making their way through. So let's take this off and just completely reposition it. If anything, I may actually just replace this with another one that has longer leads. Yeah, that wasn't even making anything. So this is a AN 7805. Alright, so I have a selection of 5-volt regulators. They're actually not 5 volt, they're all different types of regulators. So we're going to use a 7805. And something that was not on there is a thermal pad. I'm going to put that on there. Because depending on how these are set up, these can get very hot. Essentially, these regulators are not DC to DC converters. They simply burn up any extra power and turn it into heat. So if it can't move the heat away from the regulator enough, it's going to burn it up. Okay, so that's the new one in there, and you can tell the leads come out the bottom much further, so let's solder those in. Alright, so now that they're in, we got those soldered in. There's some flux residue, but I'm not too concerned about that. We just want to clip off the excess leads. And while I'm in here, I'm just going to look for some other bad joints. Might as well take care of them now while we can. And the rest of it looks pretty good. There's a few that looks like they've been touched up. At least I would hope that's the case, that this didn't come from the factory looking like this. Alright, this resistor right here, I don't know if you can see that, but you can see the blue through the board. Okay, so let's take a look at the other board just to make sure it's not going to have the same problem a couple months down the road. And, you know, this old power regulator, it's not bad. It just, the leads are too short. So I can use that someplace else. Let's unplug that. Take a look here. Yeah, see, this one looks okay. These ones look absolutely fine. So chances are it came from the factory just fine. Somebody else was in here and they just didn't do a very good job of resoldering everything, which is okay. Now, one thing I am going to do, though, come to think of it, even though this one isn't giving us a problem, I'm going to try and slide one of those thermal sleeves down. And some people watching this are probably going to yell that I'm not cleaning off the surface first and all that. Well, guess what? It lasted this long with none. So we, if anything, are improving it. It'll be fine. All right. So now it's just time to put it all back together. This is the part I absolutely hate. So looking over the bottom board, or actually it's the side, doesn't look too bad. It doesn't look like anybody was in here doing any kind of touch up on this, except way up here I see a lot of flux residue. So that's where these potentiometers are. So maybe somebody went in there and just heated them up because maybe one was loose or something. Or it was, never cleaned off. One or the other. But we're not having a problem with those, so I'm just going to leave those as is. Okay, so before I get this 100% back together, actually let me throw this screw in just so that this is a little bit more solid. Let's plug it in. Okay. There we go. .8. There's 1.9. That's close. 2.4. All right, so let's turn the current all the way down. And let's switch over to amps. 5.5, I'm sorry, 0.55, and that's 0.55. Yeah. Looks like it's working. So, this one is good to go. Just got to finish putting it back together. Okay, all done. One last time, just to be on the safe side. Let's double check. Let's plug it in. And it's on. It's not turning off. So that was the whole problem. That 5-volt regulator, the 7805, was just not soldered in place properly, and so we just replaced it with another one with longer leads and resoldered it. So we're good to go. This thing is fixed, and it'll be going back to its owner. If you have any questions, comments, or suggestions, as always, leave them down below, and I'll see you next time.